Hi, everybody. Welcome to Love Goes Live. My name is Mark Lupkowitz. I'm a molecular biology professor at St. Michael's College, and I've been making YouTube videos for my molecular genetics students, a little bit about COVID-19 and sciencey stuff. And today I thought I'd spend a little bit of time explaining how the new antibody tests that were released or approved by the FDA today, actually. So without any further ado, let's go to my PowerPoint, and we can talk about antibodies and why this may be a game changer. Okay, let's say that you, let's just call it, you get unlucky. So let's say you get unlucky and you get infected with COVID-19. And this is an image of the virus, which I clipped right here. Note, not to size. So when something enters your body that's not supposed to be there, you have cells that are called B cells, and they start off, they're called naive, such a judgmental term, I know. But so naive B cells have the genetic potential to make about 1 trillion different antibodies. And what are antibodies? Antibodies are proteins that it takes about 14 days for B cells to actually choose a fate, choose a career, if you will. They become a plasma cell, and then they start producing these structures, these proteins that are called antibodies. Antibodies look just like Y's upside down, if you want to know the truth. And their job is to recognize foreign objects in your body and then paint them, and I'm painting them sort of like the military paints targets, paint them for destruction. So a B cell, naive B cell, will take about 14 days, choose its fate in life, become a plasma cell. These live inside of your lymph nodes as well as other places. This is why your lymph nodes get swollen when you have an infection, and they will start producing antibodies. Those antibodies will then paint the target, if you will, and then what happens is your immune system attacks the target and destroys it. So this is actually how vaccinations works, and this is why for many diseases you can't get it twice. Because once you have plasma cells, they live in your lymph nodes, they're sometimes called memory B cells. They live there ideally for your whole life, but not always, as we know. And the second time you're challenged with a pathogen, let's say a virus, you just start making the antibodies you have the genetic potential to, and you're off and running. And most importantly, you don't have that 14-day period where your naive B cells are learning to make antibodies against that new foreign object. This is why, I was reading this morning, this is why dose, or they think dose matters as far as the amount of virus you get. So they've known for a long time for many viruses, including SARS, which is a type of coronavirus, the amount that you're exposed to initially correlates with your severity of the disease. And that's because if you're exposed to a very little, it takes the virus a while to get going. And your body's essentially in a race. You have 14 days to make the antibodies to destroy the virus. And so who gets to the finish line first, the virus or your immune system? All right, so why do we care if you have antibodies, or why do we care if we have the ability to detect if you've made antibodies to COVID-19? So this is the big idea. This is the big idea. If you have antibodies in your blood that recognize COVID-19, you have had the virus, even if you were asymptomatic. In fact, what that means, if you were asymptomatic, is you got the virus and your immune system won. Okay, that happens quite often. All right, so here's what was released today. This is actually a clip that's off of the company's website. This is what their sample looks like, or their testing kit looks like. Literally, all you do is you prick your finger, you put a drop of blood into that little well, you wait 15 minutes, and then you're looking for 3 lines. Let me get my little annotation tool here so you can. I can actually show you what I'm looking at here. So the C stands for control, so you want to make sure that you have a positive there. IgG and IgM, these are just different types of antibodies, and so a positive result would look like this. The control worked, you have an antibody called IgG that recognizes COVID-19, you have an antibody called IgM that recognizes COVID-19. This individual has been exposed to COVID-19 in the past. All right. This individual, on the other hand, is just the opposite. So this is what a negative looks like. The control worked, but they're not showing any positives here. So this individual has not been exposed to COVID-19. All right, so what does this mean for us as far as testing goes? Well, currently that now means that there are 2 ways to test for COVID-19. The current test, the test that we've been hearing so much about in the news, is called qPCR. I did a Love Goes Live on that earlier if you want to learn a little bit more about it. What it really does is it detects the presence or the absence of viral RNA at that moment. So really it's asking the question, are you shedding viral particles in your mucous membranes, in the nose and your back of the throat when they sample at the time that they sample? So it essentially tells you if you are currently infected. It does not tell you if you were infected in the past. It can only tell you if you are currently infected. It has an unbelievably high false positive rate. There's a paper that just came out of China, which they were showing some labs were having up to 30%, false negative. I'm sorry, false negative, I should say false negative. False negative means that you actually have COVID-19, but the test is going to tell you that you do not. So I should say false negative. My apologies for the typo. And it's a slow test. From the time of sampling to the time you get your results, in the perfect world, if you're in the lab, it'd be about 4 hours. But not in the perfect world, it's running 1 to 2 days. So it's not particularly fast. The new antibody test, all right, that just was approved today. So it determines if your body has made antibodies against COVID-19. In other words, has your body been challenged by the virus in the past? It can detect previous infections. This is huge. So what this now means is that the CDC and scientists can go out and sample the population and figure out how many of us have had it and didn't know that we had it. And that will help change both the infection rate, the survival rate, the morbidity rate, and it will better inform how we should all behave. All right. The downside is it may not detect early infection. Remember, it's detecting antibodies. It takes up to 14 days for your body to make the right antibodies. That means that early on in infection, it's not going to detect it. So qPCR, if you're trying to catch it early, the antibody test, if you're trying to ask the question, have I been exposed to this virus in the past? All right, let me stop sharing here. So take-home message, there are now two new tools, or two tools that have been listed in the fight against COVID-19. They tell you slightly different things, but both are critical pieces of information to know, and both will help public health officials manage this crisis. So I'm Mark Lepwitz at St. Michael's College. If you want to learn more about me or St. Mike's, just go to St. Michael's website. And as always, trying to rise from the ashes like the phoenix. And remember, let crisis bring out the best in you. Cheers.